In science, we like to classify things. So back in grade 9, even in the ecology unit, we looked at uh, biotic and abiotic, like things that are alive, things that have never been alive. We started chemistry this year and we looked at ionic compounds, which are metals and nonmetals that transfer electrons, and molecular, which are all nonmetals that share electrons. Another form of classification is acids and bases. So chemists use classifications to make sense of matter. Acids and bases are one type of classification. They have characteristic formulas and similar chemical behaviors. So acids are sour tasting. So if you think of a lemon, okay, a lemon is citric acid. If you think of vinegar, okay, vinegar is acetic acid. They're very, very sour tasting. They're water soluble substances. They're also molecular and they conduct electricity. Bases, on the other hand, they're bitter tasting. So baking soda would be something in your kitchen cupboard that would be a base that you might have tasted before. We put it in baking. It makes cookies rise and bread to rise. So bases tend to be bitter tasting. They are also water soluble, but they're ionic, which is interesting. So acids are molecular, bases are ionic, and they also conduct electricity. So you need to kind of understand the differences between acids and bases. Other examples of bases that you would have at home are most of your cleaners, your soaps. They tend to be more basic. Something like Drano is can be basic as well. So you don't want to be tasting all these things. Like don't be tasting your soap and such, but just realize they are bitter tasting. To tell if something's an acid or a base, we have different tests, and we're going to do a lab like that today. So we have this other thing called neutralization reactions. So if you have, say, a bad acid burn, the way you combat that is you put a base on it and it neutralizes it out. Or if you have a strong base that's burning, you need to neutralize that, you would put an acid on top of it. And we're going to talk more about neutralization reactions in the next couple units. So when you do mix an acid and base together, what you end up with is an ionic compound and water. Formulas for acids and bases. Common acids are easily recognized because their formula begins with the hydrogen. So when you add a hydrogen to the front of a compound, the ending now becomes ic acid. So here's 3 examples. So we know that's hydrogen, we know that's the sulfate ion, and when we put them together, we end up with something called sulfuric acid. So you don't even pronounce the hydrogen. But the fact that there's an ic acid in there, it means, oh, there is a hydrogen out in front. So for instance, this one is carbonic acid. This one is phosphoric acid. So you don't talk about the hydrogen in the name. The fact that it says sulfuric acid means, oh, ic acid means there's a hydrogen out in front. It's also an acid. So the name of a compound tells us a lot about it. And if you see that ic ending, it means there's a hydrogen out in front and it's an acid. Most bases are compounds that contain the hydroxide ion. So hydroxide is the OH negative. An example would be sodium hydroxide. So whenever you see the ending OH, a little bell should go off in your head going ding, ding, ding. That's a base. So acids, you look for the hydrogen in front. Bases, you're looking for the OH in the back. Okay, so OH indicates this is a base. There's another option for the bases. It says sometimes bases are more difficult to recognize. For example, substances that contain the bicarbonate, another word for bicarbonate could be hydrogen carbonate. The formula is HCO3. That's the hydrogen carbonate, or you could call it bicarbonate. That at the ending also indicates that it's a base. So an example is sodium bicarbonate, which is just baking soda, and baking soda we know is a base. So what's tricky about it is you kind of have this like hydrogen that's not right at the end, but what you have to remember is you're just looking for the HCO3, the bicarbonate, that means it's a base, or the hydroxide, that means it's a base. And again, I could give you on your test a list of different things, and I say, okay, which ones are acids, which ones are bases, just by looking at the formula. You will look for hydrogens in the front, and I'm pointing at something you can't even see. You would look for hydrogens at the front, that would be an acid. And to tell if something's a base, you look for the hydroxide or the bicarbonate at the end. Uses of acids and bases. Even though acids and bases can be harmful to the environment, they can still have uses in our society. So, for instance, H2SO4, sulfuric acid. So the sulfate ion, okay, the ending becomes ic acid. That's car battery fluid. Sodium hydroxide is a base, ends in the OH, drain cleaner. Carbonic acid, H2CO3. I know it's an acid because it has that hydrogen out in front. Basically, that's what you have. It gives the bubbles in your pop. I keep going. We have HCl, hydrochloric acid. And we find that in toilet bowl cleaner. Phosphoric acid. Okay. They also put that in soft drinks. NH3. So that one's kind of hard to see, but when the hydrogen's at the back, it tends to be the base. When hydrogen's in the front, it's an acid. So that's ammonium. It's a base. It's a cleaner. A lot of your cleaners are bases. All right, acetic acid. That's a crazy formula. That's HC2H3O2. That's vinegar. So when you hear acetic acid, you know we're talking about vinegar. Calcium hydroxide, well, it's ending in the OH, so we know that's a base, and that's lime. That's what they put on the fields to put on the grass to make the lines for like a football game or something. Magnesium hydroxide. Well, magnesium hydroxide ends in the OH, so I know again it is a base. Those are antacids. So if you have heartburn, you could take something like Rolaids, and that's what they put in is magnesium hydroxide. Now in lemonade, citric acid, okay, it's HC6H7O7. I notice the hydrogen's in the front, so it is a clue that, oh, this must be an acid. So we use acids and bases every day, and we don't necessarily realize that we are. Another one that's not here is baking soda. So baking soda, again, we use it in baking. It is a base as well.